All right, ladies and gentlemen, 8.7, surface area. Prism surface area is perimeter times height plus 2 base areas. So if we look at the diagrams on the right, when we talk about prisms, we're talking about triangular prisms, rectangular prisms, hexagonal. Cylinders are going to fall within prisms also. Um, you'll notice that we have right prisms and we have oblique prisms. Oblique prisms are ones that are slanted, and you'll see that the height is actually outside of the base. Height is the distance between the two bases, the perpendicular distance between the two bases. So notice in the picture here, our height is actually here. It's the distance, the perpendicular distance between the two bases. You got to get out of your head that the height is how tall it is in the picture. So if we look here at this first example, we have a rectangular prism, so we can use any of the sides as the base. We just need to decide which one. I'm just going to use the one that I can see here. So the perimeter of that is going to be 4 plus 10 plus 4 plus 10. So I end up with 28 for my perimeter. My height is that distance, perpendicular distance between the bases. So that's my 17 plus 2 base areas. Well, my base area is a rectangle, so I'm going to take 4 times 10. All right, 4 times 10. So then it's just to punch it right into your calculator. 28 times 17 plus 2 times 4 times 10. We get 556. If they gave us a label, oh, they do in this case, it's going to be centimeters squared. Surface area, it's area, so we square it. Here we have on a cylinder, so we're going to do perimeter. Perimeter in a cylinder, the perimeter of the base is actually circumference. Okay, so the perimeter is 2 pi r or d pi. Okay, so perimeter is that circumference, the distance around. So my perimeter here, I'm given 3 is my radius. So I'm going to say 2 times pi times 3 times my height, which is 7. Oops. So I'm going to put a 7 there. Plus 2 base areas. Well, it's a circle, and we learned in our 8.5 that the circle area formula is pi r squared. So we're going to say pi times 3 squared. All right, then again, it's just as simple as we plug it into our calculator. So 2 times pi times 3 times 7 plus 2 times pi times 3 squared. We end up with 188 point, let's round to the nearest tenth, 4955, blah, blah, blah. That's going to get me to 5 centimeters squared. Okay, surface area of a pyramid. Easiest way with a pyramid is find the surface area of each face, because in a pyramid the faces are triangles, and then add the base area. The thing you need to know about pyramids is that when you are finding the area of the side or each face, you need to use the slant height. The slant height is here versus the altitude or the height. Okay, so you want to use the slant height. So in my picture for this example, we have a slant height. That 32 is a slant height. Okay, so find the area of each face. Well, they're all the same because my base is 25 all the way around. So there's 4 of them, and I'm going to take my base times height, so base of 25 times my height of 32, divide by 2, because that's the area formula for a triangle, plus, in this case, my base is a square, so I have 25 times 25. Okay, so I'm going to just multiply them all and add them. So just into our calculators, they go. Pretty simple with that. And 25 times 25. Okay, we get 2,225, and here it says feet squared. Then surface area of a cone. This formula is on our MCA sheet. We haven't talked about yet. It says surface area is pi times the radius times L. L is slant height. L is slant height, so we use that again here, plus pi r squared. Okay, pi r squared, that's just our base area. So the first part, pi rl, is going to find the area of the top part of the cone. Okay, so pi times my radius of 4 times my slant height of 5 plus pi radius of 4 squared. And it's just punch it into the calculator. So pi times 4 times 5 plus pi times 4 squared. 113.1 centimeters squared. And here's our assignment for today.